Now we're going to go over how to add two or more vectors together. So here we have two vectors. V1 is 8 newtons north 25 degrees east, and V2 is 2.5 newtons west 15 degrees south. So let's start by drawing these two vectors. So since they give us that the north, east, south, and west, we're going to draw this on a compass. So let's start with the first one. We'll draw a compass, and we'll put in our north, east, south, and west. And now we'll draw the first vector, V1. It's 8 newtons north, 25 degrees east. That means we're going to start at the north line. So we're starting here at north, and from there we're turning east 25 degrees. So we're going towards east 25 degrees. So that gives us a vector that looks something like this. So this is V1, and it is 8 newtons long. Okay, so now let's do this again for V2. So again, I'm going to draw a compass. North, east, south, and west. And now this vector is 2.5 newtons west 15 degrees south. So we're going to start with the west line, and from there we're going to go 15 degrees towards south. So that would be a vector something like this, where this is 15 degrees. Okay, so this would be V2, and they tell us that the length of V2, or the magnitude, is 2.5 newtons. All right, so now we've drawn our two vectors. What we want to do is add them together, but they're pointing in different directions. So when we add them, we need to add them by finding the x and the y components of each one. So let's start with V1. So we're going to find the x and the y components of this. So what that means is we're going to make this into a triangle. So the V1 vector, we're going to make it into a triangle that has a horizontal line and a vertical line. And we're going to turn those lines into vectors or arrows. So when we look at V1, we can see that it's going up and to the right. So that means that the two vectors that we drew should be going up and to the right. Okay, we're going to label the horizontal vector as x, because the x-axis is horizontal, and we'll label the vertical vector as y, since the y-axis is vertical. All right, so now we're going to solve for this x and this y value. So we'll start by finding x. So I'm going to highlight the sides that I'm looking for, and I'm also going to highlight the side that I know, the 8 newtons. Okay, now I'm going to label the sides. So remember back when we were looking for a side where we had one side and an angle, we would use SOHCAHTOA. So I'm going to write down SOHCAHTOA. So when deciding whether we're going to use sine, cos, or tan, we first want to label the sides. So 25 degrees, opposite of that would be our opposite side. Then we have a 90-degree angle right here, and opposite of that would be the hypotenuse. Okay, so we're looking for the opposite side, and we know the hypotenuse. So that means that we should be using sine. So I would write sine of my angle, 25 degrees, is equal to the opposite side, which we called x, over the hypotenuse, the 8 newtons. So we're trying to solve for x, so we're going to multiply both sides by 8. So then we would get x is equal to 8 sine 25 degrees. All right, so we're done with that one. Now we're going to find the y component. Okay, so this time we're looking for the y component, the vertical component here, which we called y. So now we know the hypotenuse, and we're looking for y. Well, let's label that y. We know the opposite side, the hypotenuse, so y must be the adjacent side. So this time, we're looking for the adjacent, and we know the hypotenuse. So we're going to use CA, or cos. So we would say cos of our angle, 25 degrees, is equal to the adjacent side, which we called y, over the hypotenuse, 8.0. Now we'll solve for y by multiplying both sides by 8, and we get y is equal to 8 cos 25. All right, before we move on, let's think about whether or not these values should be positive or negative. So we can see the x vector is pointing to the right. So since it's pointing to the right, that x here should be positive, so we're good. We can leave it the way it is. And the y vector is pointing upwards. So again, we can leave that as a positive value. Okay, so what I'm going to do, since I'm adding up x's and y's with other vectors, I'm going to make a table on the side here. So I have x and y, and I have v1 and v2. So I just found out the x and y components of v1. So the x component of v1 is 8 sine 25, and the y component is 8 cos 25. Now I want to do the same thing for v2. But let's see if there's a faster way to do this instead of having to go through SOHCAHTOA every single time. So notice when I was looking for x over here, that was the opposite side, and I knew that I was just going to use sine. I ended up just saying it was 8 sine 25. So where did we get all these numbers? 8 is the hypotenuse, and then we have sine of our angle 25. But when we found the y component, we did the hypotenuse 8 cos 25. So it's either going to be hypotenuse sine of the angle or hypotenuse cos of the angle. And this is always going to be true every time you decompose a vector. So how do we know which one to use? All we have to do is think about whether we're looking for the opposite side or the adjacent side. When we're looking for the opposite side, so in our first example, when we were looking for x, we use sine. And that's because in SOHCAHTOA, the opposite side is used for s, sine. When we're looking for the adjacent side, over here, we would use cos instead. Okay, so we're always going to be using sine or cos. We're never going to use tan because tan doesn't have hypotenuse in it at all, and we know the hypotenuse, so we want the hypotenuse in there. Okay, so now we just have to decide whether we want to look for the adjacent side or the opposite side. If we're looking for the adjacent, we use cos. If we're looking for the opposite side, we use sine. And then we want to make sure that we've decided whether things are positive or negative. So again, we found the x component is positive because the vector is pointing to the right, and the y component is positive because the vector is pointing up. So let's do the same thing for vector 2. So vector 2 is 2.5 newtons west, 15 degrees south. So let's decompose this into an x and a y. So I'm going to draw the triangle like this. And notice that the x component should be pointing to the left and the y component should be pointing down. That's because our original vector is pointing to the left and down. So we'll label our sides x and y. Now let's find x first. So is x the adjacent side or the opposite side? Well, x is adjacent to 15 degrees. This is the 15-degree angle here, so x is adjacent to it. And since it's adjacent, we're going to be using cos. So we're just going to have the hypotenuse, which is 2.5, cos of the angle, which is 15 degrees. Now we need to stop and think whether or not this is positive or negative. We'll notice that the x vector is pointing to the left. That means that the x component should be negative. Now we do the same thing with the y component. So the y component is over here. Is that the adjacent side or the opposite side? Well, it's opposite of the 15 degrees. So since it's opposite, we're going to use sine over here. So we would have the hypotenuse 2.5 sine of the angle 15 degrees. Now again, we need to remember to check to see whether or not this is positive or negative. So the y component is pointing down, so that means we need to remember to put a negative here. Okay, finally what we want to do is add these two vectors up, v1 plus v2, because that's what our question is asking us for over here. So what we're going to do is type this onto our calculator. We're going to type up 8 sine 25 plus negative 2.5 cos 15. So I'm going to type that now. 8 sine 25 plus negative 2.5 cos 15. And I get 0.96613. And then I'll do the same thing with my y components. I'm just going to add them up. So I'm going to type 8 cos 25 plus negative 2.5 sine 15. And I get 6.6034. All right, so now I know the x and y components of my resultant v1 plus v2. But I don't want to just know the components of it. I want to know the magnitude and the direction. So the x component is a positive value. And since x is a horizontal value and it's positive, I'm going to draw that going to the right. 0.96613. Now the y component is positive as well, so that means it should be pointing upwards. And that value is 6.6034. Now the magnitude would be the hypotenuse of this triangle, so that would be this vector over here. So how do we get the hypotenuse? We'll recall back when we did Pythagorean Theorem, we know that this angle here is 90 degrees because the x and the y axes are always perpendicular to each other. That means that the opposite of that 90-degree angle would be the hypotenuse, which we call C. The other two sides, we can name them A and B. It doesn't matter which one's which. So we're going to use Pythagorean Theorem here. A squared plus B squared equals C squared. We're going to plug in everything that we know. 6.6034 squared plus 0.96613 squared equals C squared. Now to solve for C, we just need to square root both sides. So I'm going to first type everything into my calculator. I have 6.6034 squared plus 0.96613 squared, and I get 44.5383 equals C squared. Now I'm going to square root both sides, and I get C is equal to the square root of 44.5383, which is 6.6737. All right, so now we know the magnitude of that resultant, but we also need to find the angle or the direction. So this is the angle I'd be looking for over here. I'm going to call it theta. You can use whatever letter you like. So that angle there, theta, is always the angle from the beginning of the resultant vector. Okay, so from the tail of the vector down here. So to find theta, we're going to use an inverse trig ratio. So we are going to look for theta, and we're going to label the other two sides. So opposite of the theta angle would be called opposite. And next to the theta angle would be the adjacent side. So using SOHCAHTOA, I'm looking for the one that would have an opposite and an adjacent in it. So that would be tan. So I'm going to write tan of my angle is equal to the opposite side, 6.6034, divided by the adjacent side, 0.96613. Now to solve for theta, we take the tan inverse. So I'm going to write tan inverse of that same fraction, 6.6034 divided by 0.96613. Now I'm going to type this on my calculator. So tan inverse of 6.6034 divided by 0.96613 gives me 81.676. All right, so now I just need to express my final answer. So I would say V1 plus V2, V1 plus V2 is equal to the magnitude, which is, I'm going to round everything to the nearest hundredth, so 2 decimal places, 6.67, and the units is newtons. And now I want to give a direction. So my direction would be back, we need to go back to our northeast southwest compass. So I'm going to drop back into this final answer here. So I'll put in my north, east, south, west. So my final direction would be east. So from the east line, I'm going towards the north line. So it would be east, 81.6, I'm going to round the 7 up to an 8 degrees towards north. So east, 81.68 degrees north. So this is my final answer. V1 plus V2 equals 6.67 newtons, east 81.68 degrees north. All right, so I hope that helps. Thanks for watching.